Okay, so we have done two different types of searching. One is called linear search, okay, and another is binary search. Now we have seen that in case of unsorted data, if the data is unsorted, then we will prefer linear search. Not binary search is not possible. And if the data is sorted, then we will go for binary search, because binary search will give you less time complexity. Okay, so the worst case time complexity for both this linear search and binary search is like this. For in linear search it is order of n, for binary search it is order of log n. This is I am calling a worst case searching if I want to search any element. Now if I say what is the worst case time complexity for insertion, if I want to insert a new element in this linear search array, then what is the time complexity for linear search? If you want to insert a new element, then it will be order of 1. Okay, and if it is a binary search, then it will be you have to use order of log n. Okay, so now there is one searching technique which in ideal case, again there is one searching technique which in ideal case will give you the searching time complexity of order of 1 and the insertion time complexity also order of 1. So this is the beauty of this searching technique, and the searching technique is called hashing. Okay, so hashing is one kind of mathematical function which will store the data or either key value or any other value uh, in uh, in memory, so that your searching and insertion time complexity of is order of 1. Okay, now just suppose in our database we require the information of few students, and what are the key value for that student? Suppose the key value of the student is student id. Okay, now we required the following student IDs. Suppose we required 1 2 3 4, this student ID information. Suppose these students are failed to submit their registration fees in uh, within the last date, so we required the students who failed to submit their registration fees. So suppose these are the numbers 6732, then the 7294, then the say 8102, then suppose 95636. So these are the students. Okay, now there is suppose another student 877, then there is another student suppose 1010. So suppose these are the students who failed to submit their registration fees within due date. Okay, now if I want to search them, if my database is in a sorted order, then to search this particular, what I will do, I will compare with the middle value, then I will go for. So if I go for searching using binary search, it will take this amount of time. If we go for searching this for this in a linear search, my data is not in sorted order, then it will take this time amount. Okay, so you can easily understand that how much time it will take to search this different 7 values. Now see, if we apply a hashing technique in this particular environment, then what will happen? So what, since we are only searching among this, so what is the minimum value of this id? Minimum value is this one. And what is the highest value? The highest value is this one. So how many different values are available? There are total 10,000 different values. Okay, now from this 10,000 values, how many values we required for this particular problem? We required only 7. Okay, since this is 7, so what I will do, I will convert this, all this 4-digit numbers into a single digit. Now if we convert this 4-digit numbers into a single digit, then how many different values it can generate? For single digit, it will generate up to this, that is, it will generate 10 different values. Okay, so now see, my initially my search space, the n is this one. Okay, now my search space becomes this one, 10. So my search space where I will go for searching it is now reduced. How we can reduce to it a single number? By applying some hash function. I will apply some hash function and it will convert this 4-digit number. So I'm applying some hash function on this value, on this particular value, and I will get some hash value from this key value. Suppose these are the key values, because this is a student id, so it is a key. So from this key value, using some hash function, I will generate some hash value. Suppose the hash value generated from this is 0. The hash value generated from this, after applying the same hash function, remember, is 3. Applying this is 1. Applying this is 9. Applying this, I'm applying some value. I'm not going to discuss what is the hash function I am using. I will discuss about this. So suppose this one generating 8. Now this one suppose generating 2. Suppose this one generating 5. So these are the different key value, hash value that is generated from this key values. From these key values, we have generated some hash values. Now what I will do in memory, so this is my 10 different memory positions: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now when it generates this hash value, this particular key value will be stored into this hash value. Okay, logic clear? Then this one, 1, 2, 3, 4, it will be stored into this position. Then 1, this value 6, 7, 3, 2 will be stored into this position. It means 0 will point into this, 3 will point into this, 1 will point into this, then 9. So in 9 it will store 7294. This will point to this. Then 8. What is the value? 8102. So 8 will point to this. Then 9532. So this will point to this. Okay, then 5. So it is 9877. So it will go for this. So now this is one particular array. So how to access this particular array? By a of 0. So it will give you order of 1. So what is the searching time complexity? Order of 1. Only you are applying one. So from this is your key value. So this is your key value. Okay. On this key value, we are applying some hash function. Okay. And we are generating some hash value. Okay. And then what we are searching? We are searching a of h. So what is the time complexity of this searching? The time complexity of this searching is order of 1. If you want to insert any element, suppose I have to insert a new element, say 3, 2, 5, 8. What I will do on this, I will apply the same hash value, hash function. I will generate some value. Suppose the new generated value is 6. What I will do, I will put this value into this. So 3258. So again, what is the time complexity of insertion? The time complexity of insertion is again order of 1. So this is the advantage of hashing. Okay, and this particular table, this array is called hash table. Okay, logic clear? So now next we will discuss what are the different types of hash function. This is very important. Okay, different types of hash functions. So hash functions, just try to understand how to generate the hash function. So the first technique is called division method. By applying some division method, we can generate a hash function. How? So it will be formulated like this: h of k, where k is the key value, is equal to what I will do, k modular division, say f, where f is the, normally f is prime number. We choose f as a prime number. So what is the meaning? Suppose I have a value 1, 2, 3, 4. Okay, so this is my key value, this is my k, and suppose my prime number using which I will perform the division is suppose 7. Okay, so what I will do to generate the value, the hash value for this, so h of 1 2 3 4 will be 1 2 3 4 modular division 7. So if we perform the division operation, the remainder will be represented here. Okay, so if we perform the division operation, to 7 1 7, so 5 3 53, 7 7s are 49, so 44, 7 6 are 42. So what is the remainder? Remainder is 2. So this is the hash value that we will generate using the division method. Logic clear? This is very simple. So using this division method, we can generate the hash function. This is the most well-known technique of hash value generation. Okay, now the next one is another technique which is called middle square method. Middle square method. Okay, so in middle square method, what actually happened, suppose this is a key value, what I will do, I will first perform the square of this key value. Then after getting the square of this key value, I will consider the middle position element by rejecting uh, the left and right term. Suppose the value is, suppose it is say 1 5. Okay, so first I will perform a square of this. 1 5 into 1 5, it means it will give 15 15s are 15 5s are 75, 7 15 1 or 15 225. Okay, then I will reject the if it is a odd number, then easily we will get the middle position. So this is the middle value, so this is called mid square method. If it is a even number of values, suppose 1 2 3 4 we generated, then what we will do, we start rejecting first the least significant bit. This is the least significant bit, then the most significant bit, then the least significant bit. So ultimately we will get this is left, so this is the middle value. So this is called middle square method. This is another technique to convert your key value into some sort of hash value. So this is the hash value. Okay, this is the hash value. Similarly, there is another technique which is called folding method. Folding method is very interesting. In case of folding method, what we will do, we will try to fold the number until it becomes into our desired digit. Suppose the number is say 156. So folding means it will sum up all these things. So what is the value? The value is 12. Again it will sum up. So 3. So finally this is the hash value. So until we will get our desired, suppose we want to generate 2-digit hash value, then we will stop into this position. If we want to generate 1-digit hash value, then we will go until we get a single digit. So this is our hash value. This is called the folding method. We are folding the number again and again to get the desired hash value. So these are the different hash value generation technique. or you can say these are the different hash function. You can create your own hash function to generate the hash value. Now there is one simple problem of this hash value generation. Suppose we are using modular division 7. Okay, and suppose we have two different key values. One key value k1 is suppose 21 and another key value suppose is 28. See, for both the key values, if we apply the modular division, then we will get 0. We will get for two different key values, after applying same hash function, we'll get same hash value. So it can be represented like this: h of k1 is equal to h of k2. If this is happening, this type of thing is happening, then it is called hash collision. Okay, logic clear? Because two different, so in my table what will happen, so for 0 1 2, this is the sequence. So for 21 we have generated 0, so 21 already there. For next value 28, again we generate same value. So what will happen, both will try to occupy the same position. Already there is one element stored, so this is called hash collision. Okay, so this may happen, and there is a, that's why we always say, if ideal case, for ideal case time complexity is order of n. It means if your key values will generate unique hash value, then it will be order of 1. So this is we considered as ideal case. But if your two different key values generate same hash value after applying a hash function, then it will be hash collision. There is a high chance of hash collision if your division method or hash function is not uh, uh, good enough to generate different hash value. Okay, this is called collision. Okay, now what are the solution to this collision? The two different solutions are there for the collision. Now one solution is called linear probing, or sometimes called open addressing. Okay, another solution is clustering. Okay, one solution is open addressing, another solution is clustering. Logic clear? Now for uh, linear probing, what is the meaning of linear probing? Normally in linear probing or open addressing we use array, and in clustering we use linked list. Okay, so these are the two different techniques that we will use for, sorry, not clustering. Clustering is a technique. This is called chaining. Chaining. Okay, these are the two different solutions. Now just try to understand how to solve this problem. So first, the open addressing. Okay, so open addressing means if there is a collision, if any collision, then put the key value into the next open or free space. That is the meaning of open addressing. Now in open addressing we can use linear probing, which is the normal technique. Linear probing means it will first search for the first key value. So suppose you have applied some hash function on a key value, it generates some value, suppose L. So first you will go for L plus I, where I will start from 0. So first you will search for L plus 0 exact position, then it will go for L plus 1, then it will go for L plus 2. In this way it will go increasing and looking for the next free space. How? Suppose this is your memory or array or hash table. 0 1 2 3 4 5. Okay, suppose I am using modular division 7. The first number is 15. So 15 modular division 7, it will generate 1. So 15 in this position. The next number is 21 modular division 7, it will generate 0. So 21 in this position. Next number is 23. So modular division 0 7, sorry, 24. So sorry, 22. The next number is 22. So modular division 7, it will generate again 1. Okay, so already, so this is my L, this is my L. So first I will go for L plus I, that is 0. L plus 0, which is already occupied. So I will go for next L plus 1, that is 2. So I will go for 2. This is free, open. So I will put 22 into this position. Now suppose the next element, is say 36. So 36 modular division 7, again I will get 1. So first I will go for L plus 0. L plus 0 means 1 plus 0, that is already occupied. Then we will go for L plus 1. So 2, which is already occupied. Then we will go for L plus 2. Now L plus 2 means 3. So I will put 36 into this position. So where I am putting the element? I am putting the element in the next free space or open space. This is called linear probing. Now what is the drawback of linear probing? The linear probing drawback is it will store the data uh, in a clustering way. Means data will be clustered in a particular location. See, I am putting the data in the next free space, so all the data will be clustered in some places. So this is a problem of clustering. To solve this clustering problem, there is a concept which is called quadratic probing. Instead of linear probing, we can use quadratic probing. Okay, now in quadratic probing, what is happening? So h of k1 k, it will generate some hash value. So first it will go for L plus I square, then it will go for L plus, means I will again start with 0 1 2 3 in this way. So for the same problem, what will be the picture for the same problem? If we draw the picture, so the elements are 15 21. So my elements are 15 21 22 36. Okay, so this is my memory, and I am now applying linear probing. Okay, sorry, quadratic probing. 0 1 2 3 4 5 6, like this. Okay, so for 15 it will generate 1. So 15 in this position. For 21 it will generate 0. So 21 in this position. For 22 it will generate 1. So this is my L. So first I will go for L plus 0 square. So in this position, already occupied. So, and when there is a, so this is a collision, so next I will go for L plus 1 square. So L plus 1, it means I will go for next, so it will be put into this position. 21 22 will be in this position. Now this one is free. Now the next element is 36 modular division 7. It will generate again 1. So first I will go for this occupied collision. Next, so this 2 is collision. Then it will go for L plus 2 square, means 4. L plus 2, 4 means it will be 5. So 36 will be stored into this position. Now see, in previous, the data are congested in a some space, which is called clustering. Now data are far apart. So data clustering problem is solved using this quadratic probing. Similarly, there is another concept which is called rehashing. We are applying another hash function. Rehashing means we will apply again another hash. Suppose there is a collision. So for rehashing, what we will do, suppose using modular 7, for suppose for 20 for 15 modular division 7, it will generate 1 0 1. So 15 is already there. Okay, for the next 22, since it is again generating 1, so what it will do, it will apply another hash function. Suppose in this hash function we are using 11, Rather than 7, we are using another prime number, say 11. So in that case, it will generate 0, so it will be stored into this position. This is the meaning of rehashing. Another hash function is used. Okay. Then there is another concept which is called double hashing. Double hashing. So all this four different techniques: linear probing, quadratic probing, rehashing. Double hashing means first we will apply on this one hash function, say using 7. Then for this particular value, again we are applying another hash function like this. Here on the same key value we are using the hash function. Here for that particular hash value we are applying another hash function. So in this way we will generate a new value. So this is the concept of this double hashing technique. Okay, so this all are for based on open addressing. Where we are putting the data in the open addressing. Next, open space. Now we will discuss another technique of collision resolution, that is called chaining. Now in chaining, the concept is very simple. Suppose 15 modular division 7. So this is your 0 1 2 like this, 0 1 2 3 like this. So for this we generated 1, so 15 in this position. Next in 22 again we are generating 1, so it will be put in chaining form like a linked list. So 22 will be in this position. Then in 37, for 37 again we are generating 1, so it will be in this position. So all the elements are in a chaining form. So this is the chaining where we are using linked list. So these are the two different techniques for our solving the collision. Now the what is the difference between this? What are the advantages? Now see, in case of open addressing, the advantage is save space. Okay, and it is a fast technique. Clear? For open addressing, save space, because it is putting it in the next memory space. Okay, it is a fast technique. Okay, but the problem is it will generate clustering problem. Okay, multiple collisions, that's why it is creating some problem. In case of chaining, the advantage is it will be maintain a linked list, no clustering problem. Due to linked list there is a problem because you have to maintain a link part, a data part, but otherwise chaining is better than the linear probing. Okay, so with this I'm ending the class. Best of luck for your exam.